All right, let's talk about solving systems of equations. And there are two main ways that we're going to start out solving systems of equations: substitution and elimination. Now, you also learn how to solve them by graphing in Algebra 1. We will talk about that as well. But for now, let's talk about the algebraic ways, which are substitution and elimination. Let's start with substitution first. So substitution, the idea behind systems of equations is that you're solving equations where the x and the y in each of the two equations represent the same thing. So substitution, the basic way of doing that is you're going to take one of the equations, doesn't matter which one, and you're going to solve it for one of the variables, get the variable by itself. Doesn't matter which variable. So I look at these equations and I see the first one, it would be easy to get the y by itself, because it doesn't have any coefficient. So to do that, I would subtract 5x from both sides and then divide everything by -1. Now this tells me what y is in terms of x in this system of equations. So that means if I take this, I can then put it into the other equation for y. Now make sure you always put it into the other equation and not the equation you started with, or things start getting a little wonky. So what that will do is it'll give me something that looks like this. And this is nice because this equation now has only one variable in it, x. So we're going to solve this by distributing the 5. Then combining like terms. Moving that 100 to the other side. And dividing by 17. So we know in this problem that x is -5. So now we need to find y, because we're looking for the point where these two lines intersect. That's what the solution to this thing means. So I could plug it in anywhere. I'm going to choose to plug it in to this thing because that'll make it easiest. So my x is -5, and my y is -5. So that means these two lines intersect at the point -5, -5. So that would be the solution to the system. So with substitution, you get one of the equations, get one of the variables by itself, plug that into the other equation, solve that, and then get your result and plug it back in to get the other variable's value. Now, elimination. Elimination basically operates by saying we have two equations here, and we would like to get rid of one of the variables so we can just figure out what the other one is. Now, the idea is that we're going to be adding these two equations together or subtracting these two equations together. And while that may look weird, if I had 3x plus 4 equals 7, and I wanted to subtract 4 from both sides, that'd be fine, right? You can do the same thing to both sides of an equation. Now, if I wrote over here to the side, let's say 4y there, that 4y equaled 3x, then I could actually take away 4y from one side and 3x from the other because they're equal to each other. I'm doing the same thing to both sides of the equation, right? Now, in this case, the thing I'm writing up here doesn't help at all, right? Completely out of context. But when you're working with elimination, if you can get the coefficients of one of the variables to be the same or the same with opposite sign, that allows you to eliminate that variable by adding the two equations or subtracting the two equations together. So what I'm going to do is in this problem, I'm going to work to eliminate x. So I have a 7x in the first equation and a -2x in the second. So I'm going to take this top equation, I'm going to multiply it by 2. Now, if I multiply this bottom equation by 7, oops, let's see, 7 times 18, I think is 126. Now, if I were to take these two equations This bottom equation says that negative 14x and negative 14y is the same thing as 126. So if I add each of these things to the respective sides of the first equation, I'm basically adding the same thing to both sides. So 14x plus negative 14x, those go away. Negative 18y plus negative 14y is negative 32y. And then 34 plus 126 is 160. So this gives me an equation that I can solve for y by dividing both sides by negative 32. So now I know what y is, I need to find what x is, and I can plug it into this, or this, or this, or this. Any of those are possible. I'm going to choose the negative 2x minus 2y equals 18, because that looks the easiest. So negative 2x minus 2 times negative 5 is 18. So I'm going to do some arithmetic here. And I get that x is negative 4. So the point where these two lines intersect is negative 4, negative 5. Now, one last word before we move on. I could do any number of things to solve this by elimination. I could have actually multiplied the top equation by, say, 2 and the bottom equation by 9 if I wanted to eliminate the y's, and then subtracted the equations from each other. I could have actually divided the bottom equation by 2 because there's a common factor of 2 there, and it would have been, or negative 2 even. And that might have made it easier to do the elimination. The possibilities are pretty endless. You just have to sort of have the idea of how elimination works. You want to get the coefficients of one of the variables in the two equations to be the same or the same with opposite signs, so you can add or subtract, eliminate that variable, and then solve the rest of the way.